So hey guys, now we will be talking about the permutation. Okay, what the permutation means, right? So let's see what's the intuition behind it and what's the formula behind it. Okay, so to start with, say I am having the total m objects. Okay, these are the my total m objects, and I want to take k objects out of it. Okay, I want to take the k objects, and additionally this is the first constraint, this is the second constraint, this is the third constraint, that order matters. Okay, order matters. So what does that mean? Order matters mean, see, this is the first position, this is the second position. If to this person I am giving object 1 and to this person I am giving the object 2, it is different. If so, let's say this is a person A, this is a person B, it is different from I am giving the object 2 to the person A and object 1 to the person B, right? You can easily understand this. Take the person as a example of you and your friend, and take the object as an example of two smartphones of different company. So it really different case that which smartphone you two are getting, right? So here order is mattering, right? It's important whether you are getting the first object or the second object. Now let's see this a little bit intuitionally. Okay, so I will take a small example and then I will tell you how the formula is working. Okay, so say I am having uh, three objects. Okay, three would be too small. Let's go with, I am having four objects and my k is 2. Okay, so out of four objects I need to give two objects to the two persons, that can be A or B. Say, in how many ways I can do that? Okay, so what are the possibilities? See, so I need to give objects to the two person. So what I am saying is that let's take object 1 and 2 and give it to the person A and B. So if I am taking 1 and 2, how many ways do I have? Either I can give 1 to A, or and 2 to person B, or 2 to A and 1 to B. Do you understand this? Okay, I am hoping you know this. And in the last turn we saw what does this 4C2 means, how does it is related to choosing the two objects, right? Now say I am having, now I am done with the 1 2, I am having 1 3. Okay, so how will I distribute the 1 3? I am giving 1 to A and 3 to B. On the similarly I am giving, I can give the 3 to A and 1 to B. So do you understand that these are the total two cases, and again these are the total two cases? Okay, now no matter what I choose, I will always having these two options. So I can take, lastly 1 4, then after that similarly I can take the 2 3, 2 4, and at the end I can take 3 4. Okay, so I hope you understood now what we have done. Okay, for the every two pairs we were having the two combinations. So if I had to put this, what can I say? If I have to, uh, if out of the m objects I have to take the k objects where their ordering is matter, it would be equivalent to, first I choose out of m objects the total k objects, and then those k objects can have k factorial possibilities. Now yes, now we will talk about this k factorial. Okay, I hope till now you have understood this. Okay, so let's, okay, give me one second. Okay, see, if I am having the objects 1, 2, 3, and I want to have all their possible orderings. How, what can be their possible orderings? Either it could be 1, 2, 3 itself, or it could be 1, 3, 2 itself. Okay, it's 2, 1, 3, 2, 3, 1, and if I take the 3 as a first element, 1 2 3 2 1. So there is no other possibility. Now we know the fundamental principle of multiplication. So how we can see this? See, for the first position, I am having the three possibilities, as we saw, either one or two or three, right? In these two cases, we were having one. In these two, we were had two, and in these two, we had three as an first element. So you are with me right now, okay? So the first position had three possibilities. Now in the second position, I will be having only two possibilities. Why is it so? See, if I took any element, see, if I took element 2, if I fix it at the position 1, I can't reuse it for the position 2 and 3. Are you getting this? Because it's been fixed. So what do we left with? We left with 1 and 3. So for 1 and 3, I am having two choices for the second position. Either I can take the 1 here or I can take the 3 here. Do you get it? So say I took the 1 over here. Now I need to fill the 1 position, and what's the element I am left with? I am left with 3. So how many choices do I have to place the element over here? I am having only one choice, right? So by the principle of multiplication, how many ways we can do it? We can do it 3 into 2 into 1, which is equivalent to 6 ways. Okay, so this was for the 3. So similarly, if you have 4 elements, you want to fill the 4 positions where the order is mattering. What you can do, for the first position you will have 4 choices. For the next position or the second position, you will be having 3 choices, because if you fixed element once in the first place, you can't reuse it later. So we will be left with only 3 elements. So there we will be having 3 choices. After that we will be having only 2 elements left. So here we will have 2 choices. Okay, after that we left with the 1 element. We are having only one vacant position, and we will be having one choice. So what this makes? So 4 3 2 1. Okay, so it will be 24. Now if you, I guess you have got an idea what we are doing over here. Okay, so if I am having the what will be the answer if I am having 5 objects and the 5 position and order is mattering? So in that case, answer will be 5 into 4 into 3 into 2 into 1. So this notation, where for if I had n into n minus 1 into n minus 2 up to 3 2 1, this multiplication is also called as n factorial. Okay, so this is the first time in the lecture we are introducing the new term n factorial. So do you got the idea what does n factorial mean? Okay, it's simply the multiplication of the successive elements till n, or from n to 1, or 1 to n. Anyway, it's equivalent, as multiplication is commutative. So in let's get back to the formula of permutation. So what I said, if we are having m elements and we want to select the k elements where the order of the element matters, in that case answer would be, first, out of the m elements I need to choose the k element, and after choosing those k elements I will permute them in any order. So k factorial. So this is the main idea behind the permutation. Most of the time you will see that permutation is introduced first and then the combination. But I guess this is more natural way. Even I learned combination first and then the permutation. Okay, so I hope you have understood this. So what does the permutation means? In the next video we will be talking about the logic behind the formulas of permutation and combination. Okay guys, take care of yourself and take care of your time. If you find this video informative, share with those who are also struggling. Okay, so it will be help for them also. Thank you guys.